You know that feeling, right? You ask a chatbot a question and you get an answer back that just feels confidently wrong. It's a huge problem in AI, and it all boils down to this surprisingly human challenge. How in the world do you teach a machine to just admit when it doesn't know something? Let's get into why this is so tricky and, frankly, so incredibly important. And this is really the central puzzle here. We build these amazing AI models to be fountains of knowledge, right? But what happens when that very programming, that built-in drive to always give you an answer, actually forces them to just invent things, to hallucinate, instead of just saying, you know what, I can't find that. Okay, check this out, because this is a perfect example of the problem. On the left, you've got a question about a real game that's mentioned in the text, Twilight Princess, and boom, it gets the right answer, action adventure. But now, look at what happens on the right. Just by swapping a single word, princess, for Australia, the question becomes totally unanswerable. That game just isn't in the source text. And that simple assumption is the root cause of all this trouble. See, most of these AI models are trained with this built-in belief that an answer has to be in the text somewhere. So when they can't find a perfect match, they don't give up. Nope. Instead, they find the most relevant little piece of text they can, and they serve it up as fact, even if it's completely wrong. And that is what can make these systems so unreliable. So how do we fix this? Well, researchers have come up with two main strategies to teach AI this super important skill of abstaining, of knowing when to just say nothing. Let's break down these two clever approaches. The first path is what's called the Model-Agnostic Approach. Honestly, the best way to think about this is like adding a plugin to your web browser. You're not rebuilding the whole browser from scratch, you're just adding a cool new feature. In this case, you take an AI that already exists and you add a separate module on top of it, which is basically a fact checker. This read then verify process is a great example of how that works. It's a super logical two-step system. First, the standard AI, we'll call it the reader, goes and pulls out a possible answer. But then, and this is the crucial part, the verifier module kicks in. It's that fact checker, and it basically asks, whoa, hold on a second, is this answer really supported by the text? And if the answer is no, it overrules the reader and flags the question as unanswerable. Pretty smart. Okay, so the second path is the model-specific approach. Now, if the first method was like adding a plugin, this is like building an entirely new piece of software from the ground up. Here, researchers are designing a new AI model where the ability to spot an unanswerable question is built right into its core. It's not an add-on. It's part of the model's fundamental DNA. It's designed to be a cautious thinker from day one. But here's the thing. How are you train a cautious thinker? You can't just tell an AI, hey, be more careful. You have to show it thousands and thousands of examples. And that means creating a specialized training ground, a really tough test designed specifically to teach this skill of saying, I don't know. And that test is the Stanford Question Answering Dataset, or SQUAD 2.0 for short. This thing was a complete game changer. Researchers took this big dataset of questions and answers and did something pretty revolutionary. They intentionally added thousands upon thousands of questions that were specifically designed to be unanswerable from the given text. And we're not just talking about a few here. Get this, crowd workers, real people, were hired to meticulously create over 50,000 plausible-sounding but totally unanswerable questions. It was a massive effort to build a training environment that was challenging enough to force these AI models to get smarter. So how'd they come up with all these tricky questions? Well, this slide shows some of the clever tricks they used. They would do an entity swap, just like our Zelda example, or they'd swap a key number, add or remove a not to create a negation, or even use an opposite word, an antonym. It was basically like building this sophisticated obstacle course designed to trip up an overconfident AI and force it to actually read more carefully. So, why does all this matter? I mean, this research isn't just some academic exercise. It's all about a fundamental goal, building AI systems that we can actually, truly trust, especially when the stakes are really high. And the progress has been, well, remarkable. This chart shows what's called the F1 score, which is basically just a measure of accuracy. Back in 2018, a model called SAN was scoring around 73% on this tough SQUAD 2.0 test. But just 3 years later, a newer model jumped all the way to over 91%. That is a massive leap in performance, and it shows just how effective these new training methods really are. This quote here really gets to the heart of it.
Knowing when not to answer is often more critical than extracting a partially correct span. I mean, think about it. In critical areas like medicine or legal research or even customer support, a wrong answer can be so much more damaging than no answer at all. Admitting ignorance isn't a failure, it's a crucial feature for a reliable and safe AI.
So, where's this all going? Well, we're moving beyond just simple detection. Right now, the focus is on getting the AI to just correctly identify an unanswerable question. The next step? Getting it to explain why it's unanswerable. And the ultimate goal, the future? An AI that can say, hey, I can't answer that, but here's a related question I can answer, actively guiding us to the information we're actually looking for. And this all brings us to a final, really big question. Teaching an AI to say, I don't know, is really about teaching it the limits of its own knowledge. It's a step away from just matching patterns and a step towards something that looks a whole lot more like genuine comprehension. So if AI can master the art of knowing what it doesn't know, it really makes you wonder what other profound aspects of true understanding could be next.